Hi, what's up people, Mr. Highway here. Today I'm going to share with you about product rule. This video is part of my entire series on differentiation, and if you are learning about product rule, then you must have already covered the basic differentiation and chain rule. If you haven't done basic differentiation and chain rule, I'm going to put a card just right on top and you can click on it and watch that first. Or if you are interested in other concepts in differentiation, please check out the videos in my differentiation playlist. Alright then, product rule. Product rule is used when we are going to differentiate an expression or equation with two parts multiplied together, okay? So the textbook will write it this way: d dx uv. U here is an expression in terms of x, and v here is a different expression but it's in terms of x as well, okay? So these are expressions in terms of x. Now, if you have two expressions of x multiplied together and you're going to differentiate them, which one do you differentiate? Do you differentiate the first or differentiate the second? Well, the answer is both. You differentiate the first. The u here is the first. I'm going to call this the first expression, and v is the second expression. So I'm going to take the u, I'll differentiate it, okay? So this is differentiate the first times the second, right? So this is the second. Now, the second here is not differentiated, okay? V is the second expression and is not yet differentiated. But after it's differentiated, you get dv dx, okay? So you will have differentiate the second times the first. Okay, so this is the first here that is not differentiated, okay? So this is what I call the catchphrase, which is a phrase that I always mumble to myself to remind myself the steps of doing differentiation every time I do it. The phrase here is differentiate the first times the second plus differentiate the second times the first. So this is how you do product rule. Right, so we have an example here. Y is equal to 3x minus 1 times 2x minus 1. Now, normally we can just multiply this out and differentiate the three terms individually. However, I'm just going to use this to demonstrate the product rule, okay? So we're going to let u be the first expression and v be the second expression, okay? So let u be equals to 3x minus 1, v equals to 2x minus 1. Now we're going to differentiate the individual u and v separately. We have du dx to be equals to 3, dv dx to be equals to 2. Then we have dy by dx, and that is equals to differentiate the first times the second, okay? Plus differentiate the second times the first, okay? Differentiate the first times second, you have 3 bracket 2x minus 1 plus differentiate the second, you have a 2 here times 3x minus 1. Okay, then we are going to multiply out, expand and simplify. 3 times 2 is 6x minus 1 plus 2 times 3 is 6x minus 2. Oh, sorry, this is minus 3 here. So 6x plus 6x is 12x minus 5 here, okay? Now you must know that this question won't ever come out in your test and exam, okay? This is a very, very simple question that's just used to demonstrate the concept. So now let's look at some examples of questions that you might more likely see in the test and exam. Alright, example on product rule, part 1. We're going to find the derivative of y is equals to this, okay? So I'm just going to let u be equals to 2x squared minus 1. Let v be equals to 3 minus x cubed, okay? Now again, in this case, normally I would have just multiplied out and then differentiate the terms individually, but then now we are going to use product rule, okay? We're going to differentiate du dx. 2 times 2 is 4x. Then we differentiate the 1, it's gone, okay? Differentiate constant is equals to 0. dv dx, differentiate 3 is 0. Differentiate negative x cubed is negative 3x. 3 minus 1 is 2. Now we are going to differentiate the first times the second plus differentiate the second times the first. So I will always lay out my expressions like this: u on the left, v on the right. Differentiate u, you get du dx right below. Differentiate v, you get dv dx, write it below, okay? And then I will multiply it this way plus multiply this way, okay? This is how I always write it. So that kind of helps me remember the steps using the layout, okay? That's one of the very effective ways to help us remember. So next, we're going to do the dy dx, which is equals to, differentiate the first times second, you have 4x times 3 minus x cubed plus, differentiate the second is negative 3x squared times the first, 2x squared minus 1. Alright, now we just expand and simplify. So you have 12x minus 4x to the power of 4 minus 6x4 plus 3x squared. Okay? So we're going to simplify this. You have negative 10x to the power of 4 plus 3x squared minus 12x. And yeah, that's it. I'm done. Part 2. Same thing here. We have 3x squared plus 2 times square root of 4x plus 1. We're going to let u, let v. U is equals to 3x plus 2. V is equals to, okay, we're going to write this 4x minus 1 to the power of half. Okay, there's a power here that we have to put it in. Now, if you du dx is pretty straightforward. You just get a 3. But if you dv dx, we will have to apply chain rule here because there's a power half here outside the bracket. Okay, if you haven't learned about chain rule, please watch my video on chain rule. Okay, otherwise you should know that this power half here, you bring it down, times 4x minus 1 to the power of negative half. Power bring down, power minus 1. Half minus 1 is negative half. Whatever is inside the bracket, we don't differentiate it first. Then we differentiate whatever is inside and multiply it separately. Okay, differentiate 4x is 4. So this is going to give us 4 times half is 2. 4x minus 1 to the power of negative half. Alright, so we're going to do dy dx, which is differentiate the first times the second, plus differentiate the second times the first. Okay, so you have 3 times 4x minus 1 to the power of half plus 2 times 4x minus 1 to the power of negative half times 3x minus 2 plus 2. Now, if you think that you are done, then you are pretty far from it, okay? Because when you reach this point, you will have to factorize this expression here, whatever the result is for the dy dx, okay? And it's a standard procedure. If you find that the factorization is not easy, then yes, you're right, okay? Every student I have met will have some difficulty at the beginning, but after you get used to it, after a while, you'll be fine, okay? So, what you see here, the common factor would actually be 4x minus 1, right? It's just that this thing here has got a different power here. This is power half, this is power negative half. So what is it that we have to factorize? Now, for example, if you factor out 3x minus 6, what is the common factor? You factor out the lesser one, right? You don't factor out 6, you factor out 3, isn't it? Okay, then you have x minus 2. So you see, you factor out the lesser number, not the greater one. And so, we will factor out the lesser power. We will factor out this 4x minus 1 to the power of negative half. So we have 4x minus 1 to the power of negative half. So here's the tricky part. Now, if you have 4x minus 1 to the power of half and you factor out power negative half, what are you left behind inside the bracket? It would be actually 4x minus 1 to the power of 1. Why is that so? Because if you multiply it back in, this power negative half multiplied, same base to power 1, the powers will add up and then you get back half, right? So you will actually have 4x minus 1 to the power of negative half plus 1. Okay, and you get back this. For this one, it's pretty straightforward because you factor out the 4x minus 1 to the power of negative half. What you're left with is 2 times 3x plus 2. Alright, so we just need to leave this alone. Expand and simplify everything that's in the bracket. 3 times 4 is 12, x minus 3 plus 2 times 3 is 6x plus 4. So in the final answer, we can see that this is in the numerator, but this power negative half is in the denominator. So I'm going to write it as a fraction with the square root, because it's power half, is the square root. Square root of 4x minus 1 in the denominator. Then in the numerator, 12 plus 6 is 18, x. Negative 3 plus 4 is plus 1. Alright, so that's our final answer. So we don't just differentiate, but we have to factorize as well, okay? So now I'll put up 2 questions and you give it a try and share your answers in the comment section below. So then for product rule, the first thing you have to remember would be that this is applicable for differentiations where you have 2 expressions multiplied together, which you will call u and v, and then, or the first and the second. Then you differentiate the first times the second plus differentiate the second times the first, okay? This textbook definition, v du dx plus u dv dx, if you find that works for you, sure, why not? Then the second thing is, let u be the first expression, let v be the second expression, differentiate each one, and then multiply and add up this way, okay? Now, I would write everything according to this layout so that I can do this consistently, okay? And this also helps when I do quotient rule, which is in the next video that I'm going to shoot, where we have 2 expressions, instead of multiplied, they are in a division relationship. The formula is very similar, and you also let u be first, you let v be the second. It's almost the same, but then there are some differences. So if you do this consistently, you can remember the 2 formulas very easily. The last thing about product rule is that you have to know how to do this factorization, which can be challenging at first, but after some practices you'll be fine. Alright, let me know what other challenges you find in this product rule. Share with me in the comment section below, and I'll try to answer you as much as I can. Thanks for watching, like and subscribe, see you in the next video.